So on the next ones, 19, 20, and 21, we're talking about arc length and central angle measure. So if I have my circle, the arc length S is the length of this arc that's intercepted by the angle. And this is a central angle, they call that theta, if there's a certain radius in there. So the formula says that the arc length is equal to the radius times the central angle. The central angle has to be in radians, and so if it's not in radians, we would have to change it to, if it's in degrees, we'd have to change it to radians. In this case, we have a circle that has a radius of 13 meters. Find the radian measure of the central angle that intercepts the arc with a length of 12. So they're saying the radius is 13, the arc is 12, we want to find that angle. So 12 is going to be equal to 13 times theta. And of course, in order to solve that, all we're going to do is divide. Now we are going to round our answer to the nearest tenth, which tells me that I have to find where I stuck my calculator because I have to do some division. So I'm going to grab my calculator here. I'm going to take 12 divided by 13, and I get 0.923. Rounding to the nearest tenth then, 0.9 radians would be the measure of that angle. So on number 20, it says a circle has a radius of 19 feet. Find the length S of the arc length, intercepted by a central angle of 155 degrees. Do not round any intermediate computations. Round your answer to the nearest tenth. So, S equals R times theta. The circle has a radius of 19. We want to find the length of S if we know the central angle is 155 degrees. Our problem there is that our central angle is in degrees instead of radians, so we have to convert our degrees to radians by multiplying by pi over 180. So we are going to take 19 times 155 pi divided by 180 and then round our answer to the nearest tenth. So in my calculator, 19 times 155, shift EXP to put the pi in there. You could put the times sign in between if you wanted, but you don't need it. Divide that by 180. And so I get 51.399 with a whole bunch of nines. I'm rounding to the nearest tenth, so 51.4, and I am finding the arc length, which is going to be in the same units as my radius, so that's going to be in feet. So 51.4 feet would be my answer. 21, I'm going to try to sneak in there so that we have our formulas and stuff. It says a circular arc has a measure of 20 meters. So we know the arc length is 20 meters. It's intercepted by a central angle of 35 degrees. Find the radius. So 20 is equal to the radius times the arc length of 35 degrees. Now again, this is in degrees, so we've got to convert it into radians. So I would multiply by pi over 180. And then I have to solve that for r. So if I'm going to solve that for r, I'm going to multiply by the 180 to move it over here. So 20 times 180 equals 35 times pi times r, if I just change the order, right? All of this would still be on top. I want to solve it for r, so I still have to divide by the 35 pi. So r is going to be equal to 20 times 180 divided by 35 pi. So 35 shift pi. And I get 32.74. So rounding to the nearest tenth, 32.7, and it's going to be in meters since my arc length was in meters. Now be careful on this one when you punch it in. because I think if you try to do 35 times pi, it's not going to work. You either just have to put the pi right behind the 35 or put that in parentheses. So if you're having some issues, you have a different kind of calculator or something like that, and it's not coming out right, put the 35 times pi in parentheses so that when it's following the calculators, following the order of operations, it comes out correctly. So try to get it punched in, see if you get the same value I do to see how it works on your calculator. On mine, if I just use 35 pi with no sign in between, I don't need to worry about the parentheses. But on some other calculators, like a Texas Instrument one, you may have to. So watch that, make sure you're getting the same number so you know how your calculator works.